Hardwiring equipment that is designed to be mobile, specifically equipment on wheels, is generally not permissible. The fundamental reason stems from the nature of hardwiring itself. Hardwiring, by definition, implies a permanent and fixed electrical connection to a power source. This is in direct contradiction to the intended functionality of equipment designed to be moved freely. Such equipment relies on flexibility in its power connection to allow for repositioning and relocation as needed. The National Electrical Code, or NEC, provides guidelines for electrical installations and safety. While there isn't a single verse explicitly forbidding hardwiring wheeled equipment, the code's emphasis on safe and accessible disconnection means irrelevant. Hardwiring mobile equipment violates the spirit and intent of these safety provisions. Consider the scenario where maintenance or repair is required on the equipment. A hardwired connection would necessitate energizing the entire circuit at the breaker panel, potentially affecting other equipment on the same circuit. This is both inefficient and potentially disruptive. A plug-in connection allows for easy and isolated disconnection of the equipment for servicing. Furthermore, hardwiring can create a significant safety hazard if the equipment needs to be moved quickly in an emergency. For example, if the equipment is obstructing an egress route or posing a fire risk, a hardwired connection would impede its rapid removal. The use of a plug-in cord allows for immediate disconnection and relocation, mitigating the hazard. From a practical standpoint, hardwiring wheeled equipment introduces mechanical stress on the electrical connections. The constant movement and repositioning of the equipment constrain the wiring, leading to loose connections, insulation damage, and potential electrical faults. A flexible cord, on the other hand, is designed to withstand repeated bending and movement without compromising the integrity of the electrical connection. The appropriate method for providing power to equipment on wheels is to use a flexible cord terminated with a plug. This plug should then be connected to a properly installed and grounded receptacle outlet. The outlet should be readily accessible and located in close proximity to the equipment's intended operating area. Alternatively, a power strip or surge protector with a flexible cord can be used, provided that it is not permanently affixed to a wall, ceiling, or other building structure. The power strip should be placed on the floor or on a stable surface near the equipment. It is crucial to ensure that the flexible cord is of sufficient length to reach the outlet without creating excessive strain or tension. Avoid using extension cords as a permanent solution, as they can pose tripping hazards and are often not rated for heavy-duty use. If an extension cord is necessary, it should be of the appropriate gauge and amperage rating for the equipment being powered. When selecting a flexible cord, it is essential to consider the environmental conditions in which the equipment will be used. For example, if the equipment will be exposed to moisture, chemicals, or abrasive materials, a cord with appropriate insulation and sheathing should be selected. Also, be mindful of the cord ampacity, which is the maximum amount of electrical current the cord can safely carry. The cord's ampacity should be equal to or greater than the equipment's current draw. Equipment manufacturers typically specify the recommended cord type and ampacity in the equipment's documentation. Adhering to these recommendations is critical for ensuring safe and reliable operation. In summary, hardwiring equipment on wheels is not a safe or code-compliant practice. The use of flexible cords and plug-in connections provides the necessary flexibility, safety, and ease of maintenance for mobile equipment. Always consult with a qualified electrician to ensure that electrical installations are performed in accordance with the NEC and local codes. The NEC is updated every 3 years, so it's always best to reference the most current edition. Also, never attempt electrical work if you are not qualified and familiar with local electrical codes and safety practices. When choosing a power strip, it's important to look for one that is UL listed. AL, formerly Underwriters Laboratories, is a nationally recognized testing laboratory that tests products for safety. A UL-listed power strip has been tested and certified to meet certain safety standards. Also, make sure that the power strip has a built-in circuit breaker to protect against overloads. Overload can occur when too much current is drawn through the power strip, which can damage the equipment plugged into it or even cause a fire. Circuit breakers are designed to trip and shut off the power if an overload occurs. Another important consideration is the number of outlets on the power strip. Choose a power strip with enough outlets to accommodate all of the equipment that needs to be plugged in. It's also a good idea to choose a power strip with some extra outlets in case you need to plug in additional equipment in the future. Additionally, consider the length of the power strip's cord. Make sure that the cord is long enough to reach the outlet without being stretched or strained. Avoid using extension cords with power strips, as this can create a fire hazard. Power strips are convenient for powering multiple devices from a single outlet, but it's important to use them safely. Never overload a power strip, and always make sure that the equipment plugged into it is compatible with the power strip's voltage and amperage ratings. Also, inspect power strips regularly for damage, such as frayed cords or loose outlets. Replace any damaged power strips immediately. In addition to power strips, surge protectors are also available. Surge protectors are designed to protect equipment from voltage spikes, which can damage or destroy electronic devices. Voltage spikes can occur due to lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the equipment and into the ground. When choosing a surge protector, it's important to look for one with a high joule rating. The joule rating indicates the amount of energy that the surge protector can absorb before it fails. A higher joule rating means that the surge protector can provide more protection against voltage spikes. Also, make sure that the surge protector has a built-in indicator light that shows whether it is working properly. Surge protectors are a good investment for protecting sensitive electronic equipment such as computers, televisions, and audio equipment. However, it's important to note that surge protectors are not a substitute for proper grounding. A properly grounded electrical system is essential for protecting against electrical shock and fire hazards. In addition to using power strips and surge protectors, there are other steps that can be taken to improve electrical safety. For example, avoid running cords under carpets or rugs, as this can damage the cords and create a fire hazard. Also, never attempt to repair electrical cords or appliances yourself. Always hire a qualified electrician to perform electrical repairs. Another important safety tip is to unplug appliances when they are not in use. This can save energy and reduce the risk of electrical shock or fire. Also, be sure to keep electrical outlets and appliances away from water. Water is a good conductor of electricity, and contact with water can cause electrical shock. Finally, it's important to have a working smoke detector in your home. Smoke detectors can alert you to a fire in its early stages, giving you time to escape safely. Test your smoke detector regularly to make sure that it is working properly. Replace the batteries in your smoke detector at least once a year. Electrical safety is an important topic that everyone should be familiar with. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, when in doubt, always consult with a qualified electrician. A qualified electrician can assess your electrical system and provide recommendations for improving safety. They can also perform electrical repairs and installations in accordance with local codes. Hiring a qualified electrician is an investment in your safety and the safety of your property. When selecting an electrician, it's important to check their credentials and experience. Make sure that they are licensed and insured. Also, ask for references from previous clients. A reputable electrician will be happy to provide you with references. Furthermore, when discussing the scope of work with an electrician, be sure to get a written estimate. The estimate should include a detailed breakdown of the costs, including labor and materials. This will help to avoid any misunderstandings or surprises later on. In addition to hiring a qualified electrician, it's also important to maintain your electrical system properly. This includes inspecting your wiring, outlets, and appliances regularly for damage. If you notice any problems, such as frayed cords or loose outlets, have them repaired immediately. Also, be sure to keep your electrical panel clean and free of obstructions. The electrical panel is the heart of your electrical system, and it's important to keep it in good working order. Finally, it's a good idea to have your electrical system inspected by a qualified electrician every few years. A professional inspection can identify potential problems before they become serious. This can help to prevent electrical accidents and ensure the safety of your home or business. Electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest requirements. A qualified electrician can help you to understand and comply with the applicable codes. They can also provide guidance on energy-efficient electrical solutions. Energy-efficient electrical solutions can save you money on your electricity bills and reduce your environmental impact. For example, consider using LED lighting instead of incandescent lighting. LED lights are much more energy efficient and last much longer than incandescent lights. Also, consider using smart thermostats and other energy-saving devices. Smart thermostats can automatically adjust the temperature based on your schedule, saving you energy when you're not home. In addition to energy efficiency, it's also important to consider the environmental impact of your electrical system. For example, consider using renewable energy sources, such as solar panels or wind turbines. Renewable energy sources can provide clean, sustainable energy for your home or business. Also, be sure to recycle your old electrical equipment properly. Electrical equipment contains hazardous materials that can pollute the environment if they are not disposed of properly. Many communities have electronic waste recycling programs that can help you to recycle your old electrical equipment safely. Electrical safety is a shared responsibility. By working together, we can create a safer and more sustainable electrical environment. Remember, when in doubt, always consult with a qualified electrician. Your safety is worth it.